say that I asked you to write a program that prints out the numbers 1 through 3. You could accomplish this just by using 3 different print line statements. System.out.println1, system.out.println2, and system.out.println3. Now obviously if we run this, it prints out 1 through 3. But what if I asked you to write a program that prints out 1 through 20? How would you go about accomplishing this? We would have to continue writing out print line statements all the way, system.out.println4, 5, 6, all the way through 20, right? And you can see how that's kind of a waste of time and a waste of code. If I were to ask you to print out 1 through 50 or 100 or 1,000, then it would be too tedious to actually try to go about doing, right? So we really need a way to repeat some action over and over again. That way we don't have to write 1,000 lines of code just to print out the numbers 1 through 1,000. So in order to be able to repeat these lines of code, we need to learn about a new construct called the loop. So before we get into what a loop is and how we can write a basic loop, I'm going to modify this code a little bit. So if I had int x and set it equal to 1 and said system.out.println x, that's the exact same as what I just had, which was printing out 1, right? Now I'm just using a variable instead of the literal value 1 in my print line statement. I could change this to system.out.println x here and just reset x equal to 2. I could also do the same thing here, say system.out.println x equals 3, and our code functions exactly the same, printing out 1, 2, and 3. So what's important here is that I have this one line of code that I'm really repeating over and over again. So you want to find some kind of repeated code. And system.out.println x is what I want to repeat over and over again, but with the value of x changing. First it's 1, 2, 3, etc. I'm going to comment this out, and we're going to try to implement this using the looping structure. So a loop is a structure that allows you to repeat code over and over again until some kind of exit condition is met. So the most basic form of a loop is called a while statement, or also known as a while loop. I use the keyword while followed by a Boolean expression. Note that this is set up much like the if statement that we're used to. And this Boolean expression is exactly the same as what you're used to with branching, where I just need some kind of statement that evaluates to either true or false. This could be compound statements or anything. So we're going to come back to what we need to put in here. But this is our basic structure. Just like branching, it's good to use curly braces to define what is inside this loop body. And everything that's inside the loop is called the body of the loop. These are the things that are going to be repeated. So we said that the thing that we want repeated is this system.out.println x. So I'm going to put this in my body of code where it is going to be repeated. Now note that since I commented all of this out, x is not initialized. So let's think about what we want to repeat. If we want this to print out the numbers 1 through 3, then I'm going to initialize x here. So I'm going to declare x, start it off as 1, and then say while, again I need a Boolean expression, so while x is less than or equal to 3, then I'm going to print out x. So let's back up, look at this. We have an int variable called x set equal to 1. Again, this is a Boolean expression just like a branching statement, so it has to evaluate to true or false, and we're only going to get inside the body of this loop if this expression evaluates to true. So while x is less than or equal to 3, in this case x is 1, so while 1 is less than or equal to 3, then we're going to enter the body of this loop, so print out x. So we know that this would print out 1, right? X is 1. The difference here is that with a looping statement, flow of control does not resume down here afterwards. What happens is when I hit the end of this looping statement, flow of control loops back up to this line and evaluates this condition again. And it's going to continue in this fashion until this expression evaluates to false. So note here that after I print out 1, my flow of control comes back up to evaluate this Boolean expression. X is still 1, right? 1 is less than or equal to 3. So we're going to enter the body again. And again, it's going to print out 1. So we've made a loop here but it's going to continuously print out 1. Why? Because x is 1, and we never set it to 2, 3, etc. So just to show you what this looks like, if I were to run this, you can see that it's printing out a lot of 1s, and it's actually continuously printing out the number 1 as I'm speaking. I don't even know how many 1s it's produced at this point. This is called an infinite loop, and in order to stop this, I have to push this red button here to manually abort the program. So starting here, if I scroll up, you can't even really tell that I'm scrolling, but we've got just a ton of 1s that were printed, and it would take me forever to scroll to the top. But so what we've done here is we have made a loop that repeats some segment of code, in this case just printing 1, but it doesn't do exactly what we want it to do yet. So yay, we made a loop, but not the right one at this point. So obviously, after we print 1 the first time, we don't want to continue printing 1. We want to print 2. If I say x equals 2, like I did up here, that's not a good idea, because what's going to happen? It's going to print 1, then x is going to be equal to 2. This is going to come up and say 2 is less than or equal to 3. Print 2, right? And then x equals 2. 2 is less than 3. Print 2. X equals 2. 2 is less than 3. Print 2. And if we run it, you can see that that's what happens. We're still in an infinite loop, but a different one. I aborted the program manually. So instead of setting x equal to 2, x equal to 3, we need something generic that can be applied over and over again and isn't specific to a number. So I'm going to say x plus plus. And this works, right? Because x is 1. 1 is less than 3, so I print 1. Then x plus plus. Remember, this is the same thing as saying x equals x plus 1. So on this next iteration, x is going to be 2. 2 is less than 3. I print 2. This next iteration, x is 3. 3 is less than or equal to 3. It's equal, right? So I print 3. And x plus plus. Now, at this point, x is going to be 4. It comes back up to this controlling expression. Says 4 less than or equal to 3? No, that's false. So flow of control will continue down here. I'm going to add a print line statement here. System.out.println outside of the while loop. Just to show you that this will print out after 1, 2, and 3. And if we run this, you can see it prints out 1, 2, 3 outside of the while loop. Now, you may start to think that there was a lot kind of going into this code. If I were to take out all of these comments, it's actually not that much code. So we have this short little program that allows us to print out 1 through any number, right? If I were to change this 3 to, let's say, 50, then what is my output going to look like? 1, 2, 3, 4, 5, 6, all the way up to 4950, and then print out outside of the while loop. We'll show it. And you can see here that it printed out all the numbers and then outside of the while loop. So I can put any value in here, right? I could even get input from the user like this. And then say while x is less than or equal to whatever the user tells me. So now if I run this, if I enter 1,000, it's going to print out 1 through 1,000. So you can see it printed everything out there. If I entered 12, it would print out 1 through 12. So this is really handy. But again, designing this loop can be really tricky. So just to formally review some of the things we just saw, we're learning about loop statements in Java. A loop is a portion of a program that repeats a statement or a group of statements. The statements that are inside this loop, the ones that will be repeated, are called the loop's body. There has to be a way to exit the loop. We saw that. Otherwise, it's going to repeat forever. In Java, there are only a couple different kinds of loops, and we looked at the while statement. There's also a do while statement and a for statement, which we'll see later. But just to go over the basics of the while statement is also called the while loop. Flow of control is going to repeat while some Boolean expression is true. So notice the setup here. We use the keyword while, followed by a Boolean expression. This is set up almost identical to the branching statements that we're used to, where we use a keyword, here it's while instead of if, then followed by something that evaluates to true or false. If this Boolean expression is true, we're going to go into the body of this loop, so start executing these statements. If it's false, then we're going to continue execution outside of the body of the loop, or after this curly brace. So again, notice that the syntax is very similar. This Boolean expression can be compound using ands, ors, anything that you've seen with branching applies here. And note that the body should have a statement that eventually makes this Boolean expression false, otherwise you'll get trapped in that infinite loop like we saw. So again, the flow of control, we're going to start. We're going to evaluate whatever our Boolean expression is. If that expression is true, we're going to execute the body of the loop. Then flow of control will come back up, evaluate the Boolean expression again. If true, execute the body and continue. So you can see this looping going on here. Whenever this evaluates to false, we end the loop and continue flow of control as normal. So what's the maximum number of times a while loop can be executed? Well, we saw in our program earlier that if you don't design your while loop correctly, then you can be left in an infinite loop. So the while loop can execute an infinite number of times. What about the minimum number of times a while loop can be executed? Can the while loop ever not be executed? So let's look back at our earlier example to see. What would happen if I entered 0 in this example? So if I ran this and entered 0 as the input, before I push enter, let's think this through. So input here would have the value of 0, and x is initially 1. So the first time we evaluate this Boolean expression, it's going to be saying while 1 is less than or equal to 0. And we know that that's going to evaluate to false. So the body of this while statement will never get executed. All that should print out is outside the while loop. So if I push enter, you can see that it never gets executed. So this is an important thing to note. The while loop may never execute, so perform 0 operations, because the controlling expression is evaluated before entering the loop body in the flow of control. Our second type of loop is called the do while loop. And in this case, the loop body is executed at least once, always. So the syntax looks like this. You have the keyword do, followed by the body statement, and then the keyword while and your Boolean expression at the end. So the while and the Boolean expression are just moved to the end of the code instead of preceding the body, and you add the keyword do at the top. Note that there's a semicolon at the end because this is the end of the entire expression. In a plain while statement, you would not want a semicolon to follow your Boolean expression. So let's change our current program from a while loop to a do while loop. So what I'm going to do is I'm going to just copy this while with the Boolean expression. We're going to add the keyword do here and see how it turns purple because it is a keyword. And then paste our while expression, so the exact same expression, immediately after the curly brace that closes the body. Now I could put it here, I could put it on the next line, it doesn't really matter because remember Java doesn't care about white space. And then remember that I do need to have a semicolon at the end. You saw that when I didn't have the semicolon it was giving me an error. So if I were to run this with the value of 3, it's going to print out exactly what our normal while statement printed out. Since x is 1, it's going to print 1, increment x to 2. Then since 2 is less than 3, it's going to print out 2, increment to 3. 3 is equal to 3. It's going to print 3. X is 4. This evaluates to false, and it should print outside of the while loop. And we see it does just that. But the difference between using this do while loop instead of a while loop is if we were to run this with the value 0, our previous while statement we said would not execute because in this condition x is initially 1 and 1 is not less than or equal to 0, so it would not have executed. But in the way that this works, the flow of control forces us to go through the body of this loop at least once. So when I enter 0, x is 1, we do print out x, so it should print out 1. X is going to be incremented to 2 here, and then while 2 is less than or equal to 0, which is our input, we know that that's false. It's going to print out outside of the while loop. But there is the difference because, as you can see, it does print out 1. So again, the do while loop forces execution of the loop body at least once. So for this example, a do while loop may not have been the right choice. Do while loops are actually very handy, especially for a concept known as input validation. So let's remove all of this, and let's write a program where you want the user to enter a number between 1 and 10. So here I'm prompting them to enter a number between 1 and 10, and then I am creating the scanner object so that we can read an input. So I'm going to create an int called number and set it equal to keyboard.nextInt. We've done things like this before with branching. I could say if the number was less than 1 or the number was greater than 10, then I can print out something like nope, try again. But if I were to actually run this and enter a number like 55, then it says nope, try again, but I cannot actually try again. The program ends. Now that we know about looping, we can actually continue prompting the user until they enter valid input, so input validation. So I'm going to create a while loop that while number is less than 1 or number is greater than 10, I'm going to reprompt the user here to enter a number between 1 and 10, and then I'm also going to read in this number from the keyboard again. So if I were to run this with the value of 66, it says nope, try again, enter a number between 1 through 10. 55, enter a number between 1 through 10. Now note that it didn't say nope, try again. Why not? Because this statement, this whole if statement here, is not inside the loop. So this is the only code that will be repeated again and again. But it does work because if I enter another number like 44, it's continuing to prompt me until I enter something in the range like 3. And you can see that the program ends. If we want it to continue saying nope, try again, which it would look nicer, then I can copy and paste this inside here, right? And now, if I were to run it, 55, nope, try again, 66, nope, negative 90, nope, and then 5, the program ends. Now, this is using a while loop. So I can do input validation with a while loop, absolutely. But you can see that there's a lot of repeated code. This whole if statement, reading in a number from the keyboard, all of this is repeated, even prompting the user. And it's not really good practice to repeat code. It's tedious for you to have to copy and paste, and then it looks sloppy. You've got this duplicated code, and it makes your project longer. So instead of all of this, I'm going to transform this into a do-while loop. And you can see how much code is going to be reused instead of duplicated. So again, I'm going to take this while and move it down to the bottom, add my semicolon, and replace it with the word do. So I'm going to prompt the user to enter a number between 1 through 10, read in that number. If the number is not in the right range, I'm going to say nope, try again. While that number is not in the range, then I'm going to reprompt them. So I'm going to get rid of all of this duplicated code. This if statement is already inside the do while loop. Getting the input is already being done inside there because, remember, since I have to go through this at least once, I'm going to prompt the user and read an input, so there's no need to have it outside of the loop. So I'm going to remove this, but I am going to keep where int number was declared as an int. I'm going to remove some white space for readability purposes, and I even get to delete this enter a number between 1 through 10. All I've done here is declare variables. Then I have do, prompt the user, get their input. If it's not in the range, say nope, try again. And while it's not in the range, I'm going to continue to loop. Now, if I were to run this and say 55, nope, try again, 66, negative 15, and then of course when I enter correct value like 4, the program ends. So do while loops are really nice when you have something like this that you want done either way, and then you want to check conditions afterwards. So now let's review some of the terminology that we saw in this lesson. A loop that repeats without ending is called an infinite loop. You need to manually abort these on your computer. Now, at this point, if you write an infinite loop, it's more than likely an error, but some programmers do write infinite loops on purpose. Think about an ATM machine. It does the same interaction over and over again with a bunch of different users. And so whoever writes the code behind it has it repeating an infinite loop. These infinite loops happen if the controlling Boolean expression never becomes false. Both the while loop and the do while loop that we looked at can both repeat without ending. A do while loop must execute the body of the loop at least one time. Why? Because the Boolean expression is evaluated at the end, forcing the computer to go through the body at least one time. This is different from while loops where it's possible that the body of the loop would never be executed. Continuously looping until a user input matches specific criteria is called input validation. We saw this in our example where we continued to reprompt the user and read in input until they entered something in a specific range. We used the numbers 1 through 10, but certainly you could prompt the user to enter yes or no, or a grade between 0 and 100. And so you can see that this can be really useful for input validation. So the trickiest part about loops is not the syntax, it's really just designing the loop. So in order to design the loop body, the best thing to do is write out the actions that you need your code to accomplish, and then look for a repeated pattern. Remember how we did that in the beginning with the while loop? We didn't want literal values like system.out.println 1 or 2. We wanted to find something repeated. So system.out.println x, and then we're going to change the value of x. Some actions may need to be done before you enter the loop, so initializing variables, things like that. Make sure you have them above the loop. Then look for that repeated pattern, put that in the body of the loop, and any actions that need to be done after the pattern stops. Maybe you're computing an average and you use a loop to continue adding to the total number, and then after the loop you would want to divide, right, and actually do the average. Loops typically consist of 3 parts. You've got where you initialize your variables, you've got the body, the things that are going to be repeated, and then you need that mechanism that allows the loop to terminate. Most problems with your loops are going to occur at the beginning or end. You're either going to initialize your variables wrong, you're going to have test values that never change, like say we never updated x in that first example, and you'd end up with an infinite loop, or you could have off by 1 errors. So if I wanted to count from 1 to 3, but my Boolean expression said while my input was less than 3, then I would only print 1 and 2, so that would be an off by 1 error. That's it for this lesson.